All right, ladies and gentlemen, we are back. And here's the deal. We're going to talk about four things. Four big ideas. We'll try to make it right being big ideas for today. We have four big ideas, all right? And the first two are relatively small of the big ideas compared to the third and fourth. And we've already alluded to them a little bit, okay? So first, big idea. And if you don't yet have something, I need you to have something with which to write and something on which to write so we can get some of these things down. Okay, so the first of the big ideas is we need to talk a little bit more about horizontal lines. Not much more, but just a little bit. And we should know that the equations of horizontal lines are always, what did we say before? Y equals some number, okay? And so the equation of a horizontal line is always y equals some number. And I know that's kind of confusing for some people because when you think about the x and y axis, the x-axis is horizontal and the y-axis is vertical. So it might seem really kind of counterintuitive or a little bit weird. But you got to think about it. Well, here, this point right here, zoom in, that point right there is where y is equal to 2. So if I come up with the equation y equals 2, then it doesn't matter what my x value is, y is always 2. And I keep holding that y value constant, and it keeps being 2 over and over and over and over. And as we saw before, it created a horizontal line. Okay? So it's a little bit odd. And if it helps you to think about it being opposite, that it's y equals instead of x, that's fine. The y is the vertical axis, but it creates the horizontal lines. All right. So bottom line is every time you have a horizontal line or you want to have the equation of a horizontal line, it's always y equals some number. So for instance, if you were given a point, let's say the point 3, -5. And they said, hey, 3, -5, where is that? 1, 2, 3, 1, 2, 3, 4, 5. It's about right here. Okay, that's the point 3, -5. And maybe the problem asks for you to come up with the equation of a horizontal line that passes through this point. Well, that's easy. We know that the equation of a horizontal line is always y equals some number. So it's going to be y equals what? Well, y equals the y value right there. So it's going to be y equals -5. And that's the equation of the horizontal line that passes through that point. It's that simple. Because we know that the equation of a horizontal line is always y equals some number, if we know what the y value is, then that's what goes in place right there. So that's pretty simple. Okay? That's one of the big ideas for today, but that was a pretty simple big idea. Okay, big idea number 2. You can probably figure it out. The big idea number 2 has to do with vertical lines. And vertical lines are always x equals some number. Okay, that's pretty simple. Vertical lines are always x equals some number. And again, we said that it's a little bit counterintuitive, which means it doesn't go kind of really how you think because x is the horizontal axis and y is the vertical axis. But again, we said, hey, if you picked some x value like x equals 4, well, then I wanted to plot a point. Well, that would be right here. And if I went up on the y value, it would be, here, or here, or here, or here, here, or maybe it'd be down here. And so all of these are where x is 4. And so if I draw enough of those, I will get a vertical line. So a vertical line is always x equals some number. Like in this case, that is the equation of that line. X equals 4. Now, if someone wanted to talk to you about the slope of that one, you'd say the slope is undefined. Okay, the slope is undefined. That might sound like a weird word, but undefined means it doesn't even have meaning. And here's why. Because slope is rise over run. And think about that one. It rises a lot, but it runs none, which means you have a lot. Let's pick a number that's like a lot. Like we'll go 1,000. Over none, 0. And you are never allowed to divide by 0. That is bad. You cannot do that. Okay? Angry eyes too. All right, you never can divide by 0, and so therefore that creates a slope that is undefined. Whereas a horizontal line, we had talked earlier, that could be written as y equals 0x minus 5. That's different. This is a 0 slope, which is different than an undefined slope, but a 0 slope just means it's not going up or down. And that makes sense. That's what a horizontal line does. But a vertical line, we can't even talk about that slope because it only goes up. So it is an undefined slope. Okay, so big idea number 1, horizontal lines are always y equals some number. Big idea number 2, vertical lines are always x equals some number. So now it's time for a question. And this is going to be an easy question. But let's do exemple numero uno. Okay, ready? I want you to write the equations plural, of the horizontal, I'll abbreviate, and vertical lines that pass through -6, 8. Okay, that pass through the point -6, 8. Okay, so your job is to write the equations of the horizontal and vertical lines that pass through this point, -6, 8. Okay, we're going to pause the video right here for about 30 seconds because this doesn't take long. And I want you to come up with the equations of the horizontal and vertical lines that pass through that point. All right, now hopefully you remembered, hey, when I hear horizontal line, I know that's y equals some number. When I hear vertical lines, I know that's x equals some number. That's pretty easy. And here is my x and y values. So therefore, the horizontal line, the equation of the horizontal line is just y equals 8. And the equation of the vertical line is going to be x equals -6. And that's it. It's that easy. Okay? Yay. Hopefully that's what you got. All right. Now it's time to turn up the heat. We got to get to big idea number 3. Okay? But to get to big idea number 3, I need you to do something for me. All right? I need you to come up with the equations of 2 different lines. All right. This is more practice of what we have just got done doing. And so it's nothing new. But so what I want to do is I want to give you a couple points. Let's see here. We'll do the point -6, -6, 2, and then the point 3, 5. Okay. So there's one of them. -6, 2. And then 3, 5, yep. And then I want the other point is going to be, let's say 1, nah, not 1. Let's say 9, 7, and then the point, I don't know, 12, 8. Okay? All right. So what I want you to do right now is I want you to find, nah, I don't like that second set. I don't like that second set at all. Okay? Let's do this. How about we go, let's go 9, -7. I like that. And then we'll go 12, -6. It's a little bit better. Okay, I like that one better. Okay, here's what I want you to do. I want you to find the equation of the line that passes through these 2 points. Okay, you're going to come up with the equation. It's going to be y equals mx plus b, except you're going to have what the y-intercept is. You're going to have what the slope is. Okay? And then I want you to, as best as you can, I want you to try to carefully graph it. All right? And then for this next one, I want you to come up with the equation of the line that passes through these 2 points. You're going to come up with the equation y equals mx plus b. And you're going to have the y-intercept. You're going to have the slope. And you can put it on the same graph if you like, but I want you to also try to carefully graph that one. Okay? So this is going to be a little bit of practice. My expectation is this is going to take you, 5, 6 minutes, and that's okay. But this is what we have been practicing. And so if you're really unsure, what I need you to do is I need you to try. You need to at least try. Remember, the first thing you're going to do is you're going to find slope, which is always the difference of the y's over the difference of the x's. So if you know nothing else, start there. and then start plugging things into this equation, okay? And then try to graph things. All right, so we're gonna pause the video right here, and in about 5 minutes, I'm gonna come back and do these, and we're gonna take a look at the equations and the graphs. Ready, set, go. Okay, let's take a look. Now I gotta get rid of all this extra junk here. I got a lot of extra writing here that I don't currently need. Okay, there we go. Okay, so let's start. First thing I gotta do is I gotta find slope. And slope is always the difference of the y's over the difference of the x's. So the difference of the y's here would be what? I could say like 5 minus 2. And if I start with 5, then I gotta start with 3 on the bottom. 3 minus a negative 6. 5 minus 2 is 3. And 3 minus a negative 6 is 9. And 3 over 9 reduces to 1/3. Cool. Okay, let me erase this. There we go. And then you can do either method. You can say y equals mx plus b and plug everything in, or you can say y minus y1 equals slope times x minus x1 and plug everything in. Doesn't matter, either way. So let's see here. I'm gonna say for this one, I'm gonna use the slope of 1/3 right here, and I'm gonna go ahead and use this point. I don't really care between which point I use. So the y value is 5. So it'd be 5 equals 1/3, 1/3 times 3, plus the b value. Let's see, b, we don't know. Okay, so that's going to be 5 equals 1/3 of 3 is 1 plus b. And we subtract the 1 from both sides, and we get 4 is equal to b. So therefore, our equation would be y equals 1/3 x plus 4. That's our equation, okay? Or we could have used this other form right here. This is called point slope form. And again, we plug everything in. So we say y minus my y value of 5 equals my slope. What's my slope? 1/3 times x minus my x value of 3. So I say y minus 5 equals 1/3 x. 1/3 of negative 3 is negative 1. And then I add 5 to both sides. And I get y equals 1/3 x plus 4. And check it out. It's the same answer because math is true. Okay, so we see that that's what we get for that first one. Y equals 1/3 x plus 4. All right, and I will go ahead and graph that. Let's see, I kind of want to move this out of the way now that we've seen it. We know it. Scoot it down here. Okay, and we'll come up with the graph. And we know that the graph should be something like, there we go, like this. Okay. And so this is our y-axis going up. This is our x-axis going over. Okay, if we have the equation y equals 1/3 x plus 4, I got to have 4 on my y-axis at least. And so I went up and then go out here on the x-axis, go up a couple more. So 4 is my y-intercept. So I go up 4, 1, 2, 3, 4. And my slope is 1/3. So I go up 1 and then over 3. And then up 1 and then over 3. And then up 1 and then over 3. So it looks something like that. Okay, and hopefully that's the kind of graph you got for yours. Okay, I'm going to scoot that over. Perfect. Okay, now on to this other one. Let's look at this other one. First thing we're going to do is we're going to find slope. First thing I'm going to do is move this over. Okay, so we're going to find slope. We know that slope is the difference of the y's over the difference of the x's. So in this case, let's see, I could go negative 6 minus a negative 7 all over 12 minus 9. Okay, negative 6 minus a negative 7 is like negative 6 plus 7, so that's going to be 1. 12 minus 9 is 3, so 1/3. Okay, notice that's the same slope. That's interesting. Okay, all right, now I'm going to go ahead and plug that in. I could use the y equals mx plus b method. I don't know if you guys like that one or not, but we're going to use it. So plug everything in. I get negative 7. I'm going to go ahead and use this point right here. Negative 7 is equal to my slope, 1/3, times my x value, 9, plus b. So this is going to say negative 7 is equal 1/3 of 9 is 3, plus b. So I subtract 3. Whoa, bad things. Subtract 3 from both sides, and I get negative 10 is equal to b. So therefore, my equation is y equals 1/3 x minus 10. Okay, looks like that. And if I would have used the point slope method, I'd get the exact same answer. Okay, so now let's try to graph that, and I think I can fit it on the same one. So I got to go down 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and I'm going to plot it in red. And it's got a slope of 1/3. So I go up 1 over 3, up 1 over 3, up 1 over 3, up 1 over 3. Okay, and it looks something like that. Fantastic. So hopefully this is nothing new. There's absolutely nothing new on the board right now, nothing new done right here at all. And hopefully this is what you came up with. You came up with these two equations and a graph with these two lines. And the big question right now, which gets us back to the big idea, is what do you notice is special about these lines? And hopefully everybody in here notices that they are what? Red. No, they're red, but they are parallel. Okay? Notice they're parallel. And why are they parallel? Because they have the same slope. Both of them are going up 1 unit and over 3. And so that creates these parallel lines. And so that's the big idea that we need to know. That parallel lines always have the same slope. Okay? Parallel lines always have the same slope. So if I had a line that said y equals 4x plus 2 and another line that said y equals 4x minus 1 million, it doesn't matter how crazy off the y-intercepts are. If I pay attention to the slope, I notice they both have a slope of 4, so therefore they are parallel lines. Okay? Parallel lines always have the same slope. Okay? That's an easy one. So if the slope of one of them is 1/3 and the slope of the other one is 1/3, then they're parallel. If the slope of one of them is -4 and the slope of the other one is -4, then they're parallel. I mean, that's just how it works. Parallel lines have the same slope. Pretty easy. Okay. Now we got to get to big idea number 4. So real quick review of big ideas: horizontal lines, y equals some number; vertical lines, x equals some number; and then parallel lines have the same slope. Okay, lastly, big idea number 4. And this is going to be, we got to define something first because a lot of people are still not quite sure what this word means. Perpendicular. I had a lot of people tell me perpendicular means to intersect, it means to cut in half, it means, and they kept telling me all these things it doesn't mean. Perpendicular means to intersect, to form right angles. I guess I can write out the words. Intersect to form right angles. That's what perpendicular means. If two lines are perpendicular, it means they intersect to form right angles. If you look up at the ceiling in this room, you see all these little cross braces. They are all perpendicular to each other. They intersect at right angles. They intersect making 90 degrees. And so those are all perpendicular. Okay? Perpendicular means to intersect to form right angles. Angles. There we go. Intersect to form right angles. That's what perpendicular means. Great. Okay, so we've got perpendicular. And then we got to talk about perpendicular in terms of all of this business right here. And what I want to do is I'm going to steal this picture. Okay, and we're going to put it down here. And the reason why is I want to think about what would a perpendicular line look like. I don't want this one. This one's kind of way far away. Need some of it though. Okay. I want to think about what a perpendicular line would look like in this situation. Okay. So a perpendicular line, now I'm going to try to actually draw an actual line. And my goal is to try to make it as perpendicular as possible. Trying to create right angles. I think that's close. I'm not saying it's perfect by any means, but I think it's close. I'm trying here. Okay. And so what I want to do is I want to go, okay, so what do we know if the slope of, oh, that's chubby. If we know the slope of this one is, what was the slope of that one? It was 1/3. What I want to do is I want to say, well, what's the slope of this one? Because the goal is that these are perpendicular lines. And so with parallel, we have same slope, but with perpendicular, well, what do we notice? Well, real basic is I notice that this is a positive slope. It's going up. It's positive. And this one right here is going down. So if nothing else, it should be a negative slope. Now, what a lot of people do a quick guess is they say, oh, I bet it's the same number, but just negative. So if this one's positive 1/3, then this one will be negative 1/3, and they'll be perpendicular. But all it does is you got to think about that for just a second. You realize that doesn't make any sense. If you came down 1 and went over 3 and down 1 and over 3, you would have a slope that looked like this. Those certainly don't create right angles, okay? That right there or that right there is not a right angle, okay? So that doesn't work. Okay, so it's not that. So we gotta get rid of that. And so really we could look at this and we could almost, if this was on graph paper, we could try to figure out the slope, but we notice it's going down. So I could go 1, 2, 3, and then it goes over 1. Okay, 1, 2, 3, and then over 1. And so really this one has a slope of -3 over 1. And if we notice, what's the connection? And the connection is big idea number 4 is that perpendicular in terms of slope always means opposite reciprocal. We'll define both those words. Opposite means change the sign. And reciprocal just means flip it, okay? Opposite reciprocal. Look at that case that we had. One slope was 1/3 and the other slope was -3. Okay, they are opposites, one positive, one's negative, and they are reciprocals. We simply flip it. Okay, so when it comes to perpendicular slopes will always be opposite reciprocals. Now, parallel, that was easy. Same slope. Perpendicular is opposite reciprocals. So let's practice a bunch of opposite reciprocals. If I had a slope of 2/3, the opposite reciprocal would be -3/2. I change the sign and then I flip it. If I had a slope of 7, then, whoa, that moved fast. Then the opposite reciprocal would be -1/7. I change the sign and then I flip it. If I had one of, -4/3, okay, well then the opposite reciprocal would be I'd change the sign and flip it and I'd just get +3/4. These are all examples of opposite reciprocals. Okay? All right. So here's what we're going to do. I'm going to give you a chance to try to see if you can practice this. Now, I know I'm asking a lot, but I'm going to work out a problem, but I'm going to have you try it first. Okay, I'm not even giving you enough time to do it. Maybe enough time to do it. Give you about 4 minutes and see if you can do it. Ready? Here's the situation. I'm going to give you an equation. We'll say y equals, how about 2/3 x plus 4 million. Yep. I want you to graph it. No, just kidding. I don't want you to graph it. That would be a terrible y-intercept. Okay, ready? Here's and then I'm going to give you some point. We'll give you the 0.61. What I want you to do is I want you to come up with a line that's parallel to that line, but it passes through this point. And then I want you to come up with the equation of line that is perpendicular to this line, but it passes through this point. Okay, so I want you to come up with one that's parallel to that line and passes through this point, and one that's perpendicular to this line and passes through this point. Remember, parallel means same slope, and perpendicular was opposite, different sign, reciprocal, flip it. Okay, all right, and we can see the slope of that equation. So your job is to write the equations of a line that's parallel to that one, passes through the 0.61, and is perpendicular to that one, but passes through the 0.61. We're going to pause the video for about 4 minutes. You might not even have time to finish, but some people might have a hard time getting started. So we don't want to wait too long, and I'll work through this problem. All right, let's give it a go. Okay, so clearly the first thing you need to do is identify what the slope is. And the slope of this one is 2/3. So if for parallel, we want the same slope. So we want 2/3. For perpendicular, we want the opposite reciprocals. That means we want -3/2. We flip it and change the sign. How easy. Okay, let's see here. So what else? So then I got to look at this point. Here's my point. Okay, and now we're back to what we were doing a couple days ago. We are given a slope and we're given a point. We're given a slope and we're given a point. And this is easy. We can use either y equals mx plus b or y minus y1 equals slope times x minus x1. Either way. We're good either way, okay? So for this first one, I'll use that one. I'll use y equals mx plus b. So y is 6 equals m, the slope, 2/3 times, y is not 6. Golly, sorry. Y value is 1. Is equal to 2/3 times the slope, which is 6, plus b. That's y equals mx plus b. So that would be y equals 2/3 of 6 is 4 plus b. So I'm going to subtract 4 from both sides. I get -3 is equal to b. So therefore my equation would be y equals 2/3 x minus 3. That is the equation of a line that is parallel to this given line, but it passes through that point of 6, 1. Okay? Y equals 2/3 x minus 3. Hopefully that's what you got. And maybe you didn't. But now we're going to try opposite reciprocal. We're going to try perpendicular. So, and for this one, I'll go ahead and use this point slope form. And I'll say y minus my y value, 1, equals my slope, -3/2 times x minus my x value of 6. So I get y minus 1. I leave that side alone for a second. This I'm going to distribute. 3/2 x. Negative times a negative is a positive. 3/2 times 6 is going to be 9/2. And then I add 1 to both sides. And I get y equals... Wait, not 9/2. 3 times 6 is not 9. Oh my goodness. Sorry, guys. It's 18/2. I was doing like two things at once and dividing and then, putting it together. But so anyway, 18/2, which that thing, 18/2 is 9. Okay, so then I add 1 to both sides. I get y equals -3/2 x, and then 9 plus 1 more would be 10. And so this right here, y equals -3/2 x plus 10, is the equation of a line that is perpendicular to the original line, but passes through this point, 6, 1. Big thing to notice, some people, what they do is they solve the first one and then just reuse the y-intercept. Notice the y-intercept is different. Very rarely will it ever be the same. Okay, so don't do that. You've got to go through all the steps again. Okay, all right. Now, hopefully this made some sense. So here's what we're going to do right now. We're going to stop. I want you guys to get into the groups that you were in last time we were together. So that would have been on Tuesday. And you're going to be given 10 minutes. And I'm going to give you 2 problems like this. And in 10 minutes, I'm going to want you to come up with a parallel line and a perpendicular line, okay, for each of the 2 problems. All right, so go ahead and drag your desk where they go. I'll put the problems on the board, and then we'll pause this, and in 10 minutes, I'll work these 2 problems out. So you guys can start dragging things where they go while I go ahead and write the problems. Okay. Okay, so the first one, the equation is 2y equals 4x minus 16. I want you to come up with the line that is parallel to that one, but passes through this point, and one that's perpendicular to that one, but passes through this point. Now realize that you have to put it in slope-intercept form first to be able to identify the slope, which means you got to make it say y equals. And the next one, let's make it even a little bit more interesting. We'll say 4x minus 3y equals 7. And for that one, I want it to pass through the point 12, 2. Okay? And I want one that is parallel and one that is, yikes, go away. There we go. And one that is perpendicular. All right. Okay, ready, set, go. In 10 minutes, we'll work these out. Okay, all right, 10 minutes is up. It's time to do these. I'm gonna move this one down to give myself a little bit of room, and I'm gonna go through them kind of quickly because by now you should, and with working with other people, you should be pretty good at these, so I'm gonna kind of zip through these a little bit. Hopefully you realize that all you had to do to that first equation was divide everything by 2, and it became y equals 2x minus 8. So there is the slope. So for parallel, you want a slope of 2. For perpendicular, you want a slope of -1/2. If I use y equals mx plus b, which I do not have to use always for parallel. I can use whichever method I want. But if I use that and I plug everything in, this would say 7, that's my y value, equals m, which is 2, times my x value of 8, plus b. So this becomes 7, 2 times 8 is 16, plus b, subtract 16 from both sides, and I get, what is that, -9 is equal to b. So my equation would be y equals 2x minus 9, okay? Now for this other one, my slope is -1/2, and so I would go y equals mx plus b, and so what would it be? Y value is 7 is equal to my slope, -1/2, my x value is 8 plus b, so it's a 7 is equal, half of 8 is 4, and then got to multiply it by a negative, so it becomes negative plus b. You add 4 to both sides, and look what we get. We get 11 is equal to b. So therefore, my equation would be y equals negative 1/2 x plus 11. Okay, so those are the two equations you should have from the first problem. Y equals 2x minus 9, that's the parallel line, and y equals negative 1/2 x plus 11, that's the perpendicular. All right, for the next one. Okay, this one has a little bit more work to make it say y equals. Okay, so if we start with the equation 4x minus 3y equals 7, first thing we're going to do is subtract 4x from both sides, and we get negative 3y is equal to negative 4x plus 7. We divide everything by negative 3 at that point. The negatives cancel out, the 3's cancel out. You got y equals, the negatives cancel out. We get 4/3 x plus a negative 7/3. Blech. But here's the thing. We don't care about any of this. We're only in it for the slope. Okay? And parallel means same slope. So we want that 4/3. Perpendicular means opposite reciprocal. So we want negative 3/4. That's easy enough. Okay? And then this is my point right there, 12(2). So this time I'm going to use the point slope method, the y minus y1 equals slope times x minus x1, because that way I'm kind of sharing which way we do it. And so I'd say y minus my y value of 2 is equal to my slope 4/3 times x minus 12. I'm going to leave this side alone for a second, and I get 4/3 x minus 48/3. And so then this becomes y minus 2 equals 4/3 x. 48 divided by 3 is 16. I add 2 to both sides, and I get y equals 4/3 x minus 14. This is the equation of a line that's parallel to the original one, but it passes through this point, 12(2). Now let's do the perpendicular. So we go y minus y1 equals the slope times x minus x1. So we get y minus my y value of 2 equals my slope, negative 3/4 times x minus my x value of 12. So we get y minus 2. I'm going to leave that side alone for a second. Equals negative 3/4 x. Negative times negative is positive. 3 times 12 is 36/4. Now, 36 divided by 4 is 9. So we get y minus 2 is equal to negative 3/4 x plus 9. Add 2 to both sides. And that becomes y equals negative 3/4 x plus 11. There you go. So the two equations you should have gotten were y equals 4/3 x minus 14 and y equals negative 3/4 x plus 11. Hopefully you got those. And if you didn't, hopefully you're seeing where you made some mistakes. Okay, so what I'm going to allow you to do is I'm going to have you work in groups for the rest of the time, and you are going to get started on your homework, okay? And so you're going to try to get as much of it done as you can. And if you work very hard, then we might take some of it off so you don't have to complete the whole worksheet. All right? Have a great day.